Hi class, so today's lecture is on appendicular skeleton. So let's begin with pectoral girdle or shoulder girdle. So the pectoral or shoulder girdle includes clavicle, scapula, and well, it depends how we look at, we can also include a sternum. Usually when we discuss shoulder girdle, it includes clavicle and the scapula. So let's start with the scapula first. So here's the scapula, very interesting looking bone. So the key features is the head, neck, body, coracoid process, acromial process, and glenoid fossa. So let's define them. This fossa is called glenoid fossa. This is where articulation of the humerus and the scapula. So this is called humeral glenoid joint. So this is a glenoid fossa, very important landmark. So another important part of the scapula is the acromion process. And there's also two other important landmarks. This is called infraspinosus fossa. That's where the infraspinous muscle will be attached. This is a supraspinosus fossa. That's where the supraspinosus muscle will be attached. And an anterior part right there that is highlighted in green is subscapular fossa. That's where the subscapular muscle will be attached to. And another important part of the scapula is coracoid process. So the coracoid process and the acromion process, that's where the muscles will be attached to. So in the coracoid process, that's where the deltoid will be attached to throughout the entire ridge. And in the coracoid process, that's where the long head of the biceps will be attached to. So in the shoulder girdle, again, the humerus, the entire upper limb is attached to the scapula, and the scapula is attached to the thorax, and then it's supported by the clavicle and going all the way to the sternum. So how do you define which scapula is right or left? What you have to pay attention is to glenoid cavity or glenoid fossa. So it has to point to the lateral side, because if you look at the humerus, you see the head of the humerus has to point into the medial side. That's where the humerus and the scapula will articulate with one another. Pay attention to this particular ridge, that's the spine of the scapula, so it always points posterior side, and glenoid fossa always needs to point into the lateral side. Another bone is a clavicle, and there's important parts are acromial end of the clavicle because it's an acromial side, and sternal end of the clavicle because it articulates with the sternum, with the manubrium right here. There are a few important landmarks in the clavicle in order to tell apart which one is the left one or the right one. So if you look inferiorly, this little protrusion or elevation is called conoid tubercle. So that always has to point inferiorly. So then you have to define which one's still left or right. It's not enough. So to identify that, you have to look at the posterior border of the clavicle. So this is thicker on the lateral side in the acromion end compared to a sternal end. This posterior border kind of hyphoses compared to a sternal end. So I just mentioned that surface, it's called conoid tubercle. So let's define the differences between tubercle, tuberosity, and trochanter. So tubercle, it is a small elevation. Tuberosity, compared to tubercle, it is also elevation, but it is a little bit bigger elevation. And you can actually palpate on your tibia. And the third elevation is a trochanter. So this is an femur, so that's a huge elevation. So they are important landmarks. That's where the tendons of the muscles are usually attached to. Alright, so now let's go to a humerus. That's the bone of the brachii, upper arm, so it articulates with the glenoid fossa. So important landmarks here is this sulcus. You see there's like little groove here. So it's called sulcus of the humerus, it's called the groove of the humerus, or it's also called intertubercular sulcus. That's where the tendon of the bicep will pass through. It would be sitting right there, and will cross over this joint and will be attached to the scapula, to this supraglenoid tubercular region right here in the tuberculum. Other important landmarks, so you can tell the differences between left and right humeruses, is this surface. So this surface is called medial epicondyle. So medial epicondyle is this bony projection, and it always points medial side. So in order to tell the differences between left and right humerus, you have to pay attention to this medial epicondyle of the humerus. So, but it's not enough. Also, you have to pay attention to a head of the humerus, because it also has to point medial side. And then another important landmark here from the posterior side is this fossa. This is called olecranon fossa. The reason that it's called olecranon fossa, because the olecranon is the part of the ulna. So the olecranon will fit in this olecranon fossa, and that will create a hinge joint of the forearm and the upper arm. So there are other important landmarks. This in particular is called trochlea. So it's called trochlea, and if we will isolate the ulna, so in ulna, this part, this right here, is called trochlear notch. So the trochlear notch will hinge in the trochlea. This landmark right here on the lateral side is called capitulum. So the capitulum will articulate with the head of a radius. So altogether, these three bones will create this hinge joint. So in order to tell if it's a left or right humerus, pay attention to the head of the humerus that always points towards the glenoid fossa. Then this little projection that is called medial epicondyle, and then posteriorly olecranon fossa. So now let's proceed to a forearm. So the forearm, or antebrachial, has two bones. This bone is called radius, that's the lateral bone, and this bone is called ulna, that's a medial bone. So let's look at the ulna first. So the ulna posteriorly has olecranon, trochlear notch, and in distal part of the ulna, this little projection right here, or the process, is called styloid process, like styloid that you're writing with in your tablet. So there's also kind of important landmarks here. So this called this coronoid process, because this little fossa is called coronoid fossa. And posteriorly, this process right here, this ridge, is called olecranon process. So this is the olecranon process because it fits in olecranon fossa, and this is a coronoid process because it fits in the coronoid fossa right here, coronoid process right here. So then how are you able to tell the differences between the left and the right ulna? So the styloid process of the ulna points in the medial side. So but like if you take two bones, you see like the ulna and the radius, their styloid processes kind of encasing the wrist. So one styloid process goes from the lateral side and another styloid process goes from the medial side. Another way to tell if it's a left or right, when you hold the ulna, this process is kind of pointing towards or closer. You see it's kind of slanted to the left, so it's points towards the medial epicondyle. So then you know that it's the part of the right forearm. So now let's look at the radius. So in the radius, that's a head. Then this is a articular area of the proximal part of the radius that articulates with the capitulum. And then we'll also define that this is a styloid process. Then this light elevation is called radial tuberosity. That's where the muscles are attached to. So how do you tell if it's a left or right? So it's very easy for the radius, because if you will rotate the radius and look at the posterior side, so there's like ridges, one ridge, another ridge, another ridge, and there's like extra type of elevations called tubercle, like dorsal, because it's on the dorsal side, radial tubercle. So now we just define the scapula, clavicle, humerus, radius, and the ulna. So brachy, enterbrachy, or arm, forearm, and then the hand. So the hand includes phalanges, metacarpals, and the carpal. So the carpals, these 8 bones, comprise of the wrist. So the wrist distally articulates with metacarpals and proximally articulates with the distal part of the radius and the ulna. So there are 8 carpals, and each carpal has its own distinct name, but you do not really need to know them. However, if you want to, so there's like 2 rows. One is the proximal row and another is the distal row. So the proximal row has 4 bones and the distal row has 4 carpals. So the proximal is scaphoid, lunate, triquetrium, and the pisiform. And the distal row includes trapezium, trapezoid, capitate, and humate. But it's not that important for our class. And maybe there's like 2 important carpal bones because they truly articulate with the distal part of the radius. So the scaphoid articulates, and it's a lateral carpal, articulates with the lateral side of the radius, and the lunate articulates with the medial part of the radius. So it's a scaphoid and the lunate. So then distally there are other 5 bones. They're called metacarpals, and the metacarpals, it's our palm, so we do not really kind of see them. They covered by the skin, so it's like 1, 2, 3, 4, 5, and we identify them from the lateral side. So there would be metacarpal 1, metacarpal 2, metacarpal 3, metacarpal 4, and metacarpal 5. And the distal facets of the metacarpals are our knuckles, these knuckles. So these knuckles, if you clench your fist, so these are the knuckles that you can actually see them. That's them in metacarpals. So then a pollex, or the thumb, has only 2 bones, right? Proximal and distal. And then other digits, starting from the second one, has 3 bones. 1, 2, 3. So it's a proximal, medial, and a distal. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. So there's 12, 4 multiplied by 3, 12, and other 2, it's 14. So it's 14 digits, then 5 metacarpals, then 8 carpals, 2 in the forearm, and 1 in the arm. That makes up a 30 bones of the upper limb. So we basically conclude the upper division of the appendicular skeleton. Thank you very much. Have a great day.